Okay, this is question number 8. f of x is equal to log of 2x minus 5 plus 2x squared minus 30, where x is greater than 2.5. Part A. Show that f of x equals 0, has a root alpha in the interval 3.5 to 4. A typical question, question 8, this one. It's a very, very typical question. So we need f of 3.5. Stretch your calculator for that one. Get the calculator out. Log of 2 lots of 3.5 minus 5 plus 2 lots of 3.5 all squared minus 30. And you get the solution minus 4.80. 4.80685. And then we need f of 4 as well. So let's go hop back straight into the calculator. Substitute in 4 for the benefit of myself. And funnily enough, you do get 3.0986. 0986. Okay. We say, as there is sorry for this question, it's not working for me for some reason. Hold on. So I can write as there is a change of sign and the function is continuous. You must have both of these for this mark between 3.5 and 4. There must be a root alpha such that 3.5 is less than alpha, which is less than 4. Okay. That is what you have to write to finish that question off. Okay. So make sure you've got those two written down, because I'm going to move on. Okay, part B. Apply the Newton-Raphson Method procedure once to obtain a second approximation for alpha, giving your answer to 3 significant figures. So we've got the Newton-Raphson Method, and the Newton-Raphson Method is given to you in the formula booklet. Okay, so if we had f of 4, which was the 3.099, and f prime of 4 is 16.67, so you're given those on the question, then xn plus 1, so the formula from the formula booklet is xn, take away f of xn, all over f prime of xn. So the formula book, but we are recommending as a school that you basically learn that one. Okay, because you'll be using it a lot. So the second approximation then, so x2 or x squared, it's a subscript, so it'll be x2. x2 with 4 minus the 3.099 all over the 16.67. Okay. Calculator again. Up to the calculator we have 4 minus the fraction 3.099 divided by 16.67, and you get 3.81 to 3 significant figures. Okay, that is part B. Okay, the 4, by the way, is coming from the x1 in the question. A student takes 4 as a first approximation to alpha. Okay. Part C, show that alpha is the only root of f of x being equal to 0. Now, there's kind of 2 ways you can look at this, but not with a highlighter pen. That might be a good idea. 0 is equal to log of 2x minus 5 plus 2x squared minus 30. That's equal to 0. Okay, so 30 minus 2x squared will be equal to log of 2x minus 5. So, if we draw a curve, okay, so we got, in fact, that's a very, very terrible looking curve. Let's make that a bit better, shall we? So, like that. So we've got a curve coming up, and it will cut through the x-axis, as we know. But then it's got this y equals log of 2x minus 5 coming through, and through there. So if we get a highlighter, and we highlight this here, this, we have to type this one again, as, in fact no, there is only one point of intersection there is only one point of intersection, only one solution, where x belongs to the real numbers for f of x being equal to 0. Okay? It's a really bad sketch of a diagram. Basically, the 30 is this little bit up here. This is the 30. Okay? And this intersection is where they basically cross, because it's going to have x is 5 over 2 as an asymptote. Okay? Because it won't physically touch the curve, but it'll get down close. Okay? Reason? Because you can't define it when log of 2x minus 5 is equal to 0. You can't have log of 0 because it is undefined, so it has the asymptote. It's a vertical asymptote as well. X is 5 halves. Okay? That's how you can get all the marks here for question number 8.